Hello. As I explained in the previous video on lists in Python, Python is perhaps irritating in that it offers multiple ways to complete every programming task. In this video, I'm going to explain another way where we can do what we have previously done using loops, using a different technique which is known as recursion. As we did in the previous video, let's start with some code that we already know how to write and that is now familiar. As you should know by now, the code shown here creates a numpy array with 10 elements, and this array is called myArray. There is then a loop that sets the 10 elements of myArray equal to the first 10 non-negative integers. Recursion, which is the method we are looking at today, allows us to write this code without a loop. The way this code would be written using recursion is shown here. The first 4 lines of code here is a function definition, so we start execution here. Furthermore, as you can see, this line of code is exactly the same as the first line of code in the program at the top of the slide. This creates a numpy array with 10 elements, and this numpy array is called myArray. All of the elements in the array are initially set to 0. With the array set up, we then call the function setElement that is defined at the top of the code. If we look at what happens within the function, notice that I is set equal to 0 in the call, which is less than or equal to 9. So this if statement is not triggered during this first call. We then set the 0th element of myArray equal to 0, just as we did on the first passage through the loop in the previous piece of code. The next line is where we use recursion. Recursion is basically calling the function that you are currently executing from within that same function. So on this first passage here, for instance, we call setElement with the first argument equal to 1, as I is equal to 0, and thus I plus 1 is equal to 1. Now, on the second passage through the loop, I will equal 1, and we will thus set the first element of myArray to 1, and then call setElement with the first argument equal to 2, i.e. I plus 1. Every time we call setElement, in fact, we will call setElement again, as this function call is within the function. The only time that a call to setElement will not trigger a further call to setElement is if I is greater than 9. In this case, we return from setElement before the code has the opportunity to call setElement once again. As you can hopefully see, through recursion, we thus achieve what was previously achieved using the for loop in the other code. Everything that can be done with iteration, for loops, can be done with recursion and vice versa. In both computer programming and mathematics, we use both of these ideas interchangeably. Sometimes recursion is more useful and compact than iteration, and vice versa. To get comfortable with these two ideas, it is thus useful to start asking yourself how you could do something you completed with recursion using iteration, and how you can do things that you've completed with iteration using recursion. As you work through the exercises that follow, which you will solve using ideas from recursion, you should thus always ask yourself how you could write these codes using for loops instead. Good luck, and thanks for your attention.